Okay, so here are the last notes. Before I start talking about HL, I want to go ahead and talk about the not congruent. I know that in my class we have discussed one of them that's not congruent, and but there are two different ones. So when we did the activity before Thanksgiving break with all the little sandwiches and the triangles, there were two of the charts that the angles should have been different, and it was okay that if they looked different. And that's going to be these two right here. What you notice here is we have three angles marked congruent, so that would be what we call AAA, AAA. Okay? If you have three angles that are congruent, you are not going to necessarily have two triangles congruent. So AAA is not a way of proving congruency. The other one down here is we have a side, and an angle. And yes, I know a couple of my classes we kind of joked about that, but I am going to go ahead and please make sure we write SSA on that one, not the other way around. Okay? And if you do look at it the other way around, I've always told my geometry students, it's not a word you're supposed to say. It's not a way to prove congruency. And a no-no word, a no-no way of proving triangles are congruent. All right? So HL, the last of the five. What's going to happen here is HL is going to stand for hypotenuse leg. So you actually are only going to need two things congruent on here. You're going to need the hypotenuse and any one leg of, well, where do we see hypoteni? Plural for hypotenuse. Only when we have right triangles. So you have to have a right triangle. So you're going to have any one leg of a right triangle, and that's what we're going to highlight, is that right triangle. You do not have a right triangle, automatically cannot use HL. So here, if we notice, we're going to put our 90-degree angles right here. The first thing we need is our hypotenuse. And as we've learned, your hypotenuse is always going to be across from the 90-degree angle. So across from the 90-degree angle, that side has to be congruent on both triangles. No ifs, ands, or buts about that. And then you need one of the two legs, but it has to be the corresponding. You can't have this leg on the top triangle and then this bottom leg on the bottom, on the other triangle. Can't do that. They have to be the corresponding legs. Okay? And let's look at the last foldable for this unit, hypotenuse leg. Remembering that we have to have a right triangle, okay, for this to occur. And then on here we're going to start off with first, if we have our hypotenuse, which again, our hypotenuse is located across from the 90-degree angle. So that would be this segment right here. Segment BC will be congruent to the other hypotenuse, segment EF. And then you need one leg here. They have marked this leg, segment AB. That one is congruent to the corresponding leg, segment ED. Sorry, that needs to be DE. We need to follow the order of the letters. A goes with D, and B goes with E. It's only two things. And therefore, after that occurs with your right triangle, you can confirm that triangle ABC is congruent to triangle DEF. Okay, remembering, this is very, very important. No right angle, no right triangle, no HL. So let's take a look. Uh-oh, perpendicular things going on here. So we've got to now, we're going to have to remember our perpendicular lines. All right? First statement is not there, but we know it's going to be a given. So let's take our first given. That's going to be your segment AB is perpendicular, that upside down T, to segment BC. And then we want to go and we want to make sure that we are marking that. So here we have segment AB is perpendicular to segment BC. Perpendicular meaning we're going to have a 90-degree angle. So since I have a 90-degree angle, I might have HL here. Might. Okay. Next statement says angle ABC is a right angle, because we have those words there and we're saying two lines are perpendicular, therefore they form a right angle. This is your definition of perpendicular lines. We haven't seen this one in a while. If two lines are perpendicular, they form a right angle. That is your definition of perpendicular lines. Okay? Next, we actually have the whole thing filled out for us because we actually have not covered this. So I made sure to leave that one there for you. But triangle ABC, so ABC, this triangle right here, okay, I want you guys to see how these actually are going to overlap. There's triangle ABC, and then here's your other triangle, right? Triangle ABC is a right triangle. This is your definition of a right triangle. Because the angle is a right angle, the triangle is a right triangle. Notice the difference between those two. And that's how we come to the definition of a right triangle. The definition of a right triangle is a triangle with a right angle. Statement number 4 is saying that segment DC right here is perpendicular to segment BC. So what that means is we have a 90-degree angle. This right here is another given up top. Now we need to figure out what can we say over here that gives us the definition of perpendicular lines. We can kind of go up here and cheat a little bit. What happened whenever we said there was a definition of perpendicular lines? We stated that an angle was a right angle. So we need to go where that 90-degree angle is, and we need to identify that this angle is a right angle. So we would say angle DCB is a right angle. Okay? That's your definition of perpendicular lines. You have two lines that are perpendicular, therefore you're going to have a right angle. Again, we went ahead and helped you out with statement number 6. So now because we have perpendicular lines, we've got the 90-degree angle, we can now say that triangle DCB, this triangle right here, is a right triangle because that's the definition of a right triangle. If it has a right angle, it's a right triangle. 7 is completely blank, but if you look up top, we have another given we have not used. So we'll say segment AC, right here, this whole long segment right here, is going to be congruent to segment BD. That's going to be this whole line right here. Okay? And this is a given. Next, we're going to look at our reflexive property. This one's a little different than what reflexive properties in the triangles that we have seen. Since we're not given the actual statement, we need to go find out what's happening. And what I want you guys to see here is, again, we have two different triangles. We have triangle ABC. ABC. We also have triangle DCB. So we have DCB. We have this triangle. When we do this, now we can see, hopefully, which side overlap, which sides are shared. So right here, you can even see what's great about the colors I use is it turned a different color. So segment BC is shared by both my triangles. So I could say segment BC is congruent to segment BC. And that will be my reflexive property. And I need to make sure that I'm marking that. Now with this, instead of the S's and the A's, whenever we marked segment, AC congruent to segment BD, this ended up being across from our hypotenuse, across from our 90-degree angle, giving us our hypotenuse. And then we notice here, the other side, this is going to be the little leg. So we could conclude that our two triangles are congruent based on HL. What were our two triangles? triangle ABC was congruent to triangle DCB. A lot of stuff in there. Okay. The next property, the next proof down at the bottom, we'll take a look at. We are going to start off with triangle JKL. So we have J to K to L, this triangle right here, and triangle LMJ, this guy right here, are right triangles. Gave it to us. Statement number 2 is blank, but the reason we're going to write the statement is because it's another given. So up here, we see our other given is segment JK is congruent to segment LM. So go over and look. JK right here is congruent to segment LM over here. Next, statement number 3 says that segment LJ is congruent to segment LJ. This guy right here, this is your shared side. So we have our reflexive property. We can mark those congruent. We're again going to determine that these two triangles are congruent based on HL. Across from our 90-degree angle is going to be our hypotenuse, and then we just need one other leg congruent. And so we've got our HL. So we could say that triangle, first triangle was JKL. In fact, we can even put that in the same color that we outlined it in. JKL will be congruent to triangle LMJ. But we're not done yet. We have now proven that two triangles are congruent. Therefore, once the triangles are proved congruent, we can then state that any other corresponding parts of these congruent triangles are congruent. So this brings up our Cpctc. And there you go.